started. So some introduction about the topics that we will have today and who are the presenters. So first we will look into measurements for child devices. So how measurements can be applied to child devices underneath FinEdge. Then follow up support operations management that will be presented by Lucas. So how can you manage what supported operations your device supports, your FinEdge device. Then Albin will show us a little bit about Apama Project management and the Apama plugin for software management. And finally, we will see something by Alex about log file reporting for software management. So for debugging cases, for error installations, uninstallations of software management, and how you can restart FinEdge remotely and locally by your operation. And with that, I will go over to the first presenter, Rina.
Okay, thanks, Sebastian. Yes, I'm going to start my demo about measurements for child devices. Let me share my screen. Okay, so finally, we are very happy to announce that 0.5, wait, my display is freezed. Wait, seriously? Okay, we are happy to announce that finally the thing is supporting child devices. But also be aware that our current support is only to Cumulosity. So this child device function is not yet supported for Azure IoT. So, okay, now I already connected my ThinkEdge to Cumulosity. So to do Tech Connect CHY, and then please check that. So mappers status. So important that we basically extended the mapper function. So Cumulosity mapper function. So now mapper is active. Okay, then something not good happened. Okay. Okay, then so first in the Cumulosity, let's check my Cumulosity. So this device is my ThinkEdge device. So now if I go to this child one, child 4 is existing, but it doesn't matter for today. So now I want to send a measurement with the name for new device child 1. So it's a child 4 I already created, but I want to create a new child 1 device. Then, sorry. So let's go to MQTT broker. So before, for when we want to report the measurements to ThinkEdge device, our topic to publish is TEDge measurements, but this is for the parent device. So now we extend it. If you want to publish measurement to child device, so you need to publish to the topic TEDge measurements and child device ID. So now I want to have this child one in my under my TEDge parent device. Then I subscribe CHY measurements create, and the CHY SUS. So let's publish this one. So now you see that. So if we publish to this child device topic, then Cumulosity mapper first creates this 101. This is a smart REST to message to create a child device to Cumulosity. Then also, yes, like our parent device measurement creation. So we send JSON over MQTT to Cumulosity. So let's go to the Cumulosity child devices. So now you see child one, this one, the new one, that I created, and the point is the name. You will see that it's a child one. It's the same name as you specified in the topic name, and the type is CHIO child. And if you go measurements, you see that now because I published acceleration XYZ, so you see that it's created. Then, okay. So now Mappa is still running. When I publish another message to the same topic, then you can see that. So Mappa doesn't create 101 message anymore because child devices already exist. Yeah, another measurement message comes to Cumulosity now. And this information, so the child device is existing or not, is collecting inside Mappa process. So that means, so it's runtime memory. So if I restart the Mapper, so now Mapper doesn't know this child device is existing in Cumulosity or not. Then actually, if I send a new message, so Mapper sends 101 again. But in Cumulosity definition, smartrest definition, if the as a device with the name is already existing in Cumulosity side, that they want to create a new one, so just they will ignore it. So it doesn't harm our child device function. Okay. Yes. And so I had a child for already. Then you can see that, okay, child, for example, child 4. Now I send the measurements. And again, yeah, now you can see that I created the measurements. So just one Mapper process addresses, so all child devices measurements publish. So it's like a touch measurements for parent device. So you just need one Cumulosity Mapper process. So it's the same design as before.
Thank you, Rina, for the presentation. And
you're welcome.
We can go over to the next presentation, which will be supported operations management by Lucas.
Yes, so I'll show you some new support for operations in Finnish. As we all know, that till very recent, till basically today or till 0.5 release, adding new operations to Finnish wasn't very straightforward. And even if we managed to do that via overriding the hard-coded messages with support operations to Cumulosity, we would still lose some built-in operations. And with 0.5, we now added a system on an interface on Finnish, which allows you to declare the operations as well as provide either, we call it native supported operations, like, for example, one built into the Finnish, for example, software updates, or as you're going to see later, restart of the device, or as a third-party developer or partner, you can also add these, let's call it third-party supported operations whenever you need to. So for my demo, I have my device here. Currently, this device hasn't got any operations declared. So if I look into my device's profile, so my device 31801 as my Gamma device currently has 0 supported operations declared in Cumulosity, and with the new version of Finnish, it is fairly straightforward to add new operation. So I'll add the new device. Sorry, update the latest to the latest. That will basically add, new operations. And when I start my Mapper now, we will see that over our MQTT, we have sent the 114 smart rest message, which is declare supported operations for the device with a set of inbuilt operations. So now on my device, if I just quickly refresh that, we'll obviously see the updated GUI with all the new operations. So I added three operations. One is the restart of the device. We now also have software management as well as log download for the operations. So whole of this process is pretty much automated now with the 0.5 release, and I will quickly try to explain you what's going on. So for the operations, we added additional configuration in the file system for Finage. So whenever I want to declare a new operation, I need to add a new file in this directory. So after you install the version 0.5 of Finage, the new directory here in this etc Finage will be created called operations. And by default, because we have two mappers currently supported natively, is the Azure mapper and C8Y, we will create the two additional cloud directories. And all the files inside these directories, like for example here, C8Y log file request, C8Y restart, C8Y software update, will be treated as declaration of supported operations for finished device. So whenever the appropriate mapper starts, so in our case, we have few operations declared for Cumulosity. Whenever it starts, it's going to pick up all the files from there, and it's going to use its file name, so exactly that, as a declaration of those operations. So for example, if I remove, sorry, just quickly, if I remove all of these operations from this directory, so assuming my device didn't have anything, and I restart my mapper, the mapper will pick up this directory as empty, and therefore, assuming we have zero operations which we support on Finage, besides obviously measurements. And as you can see here, the 114 message will be sent to Cumulosity, and therefore deeming my device pretty much just a sensor which can send measurements. So no more restart, no more other operations. Okay, so I need to quickly reinstall that to recreate the files. So just for not native support of these operations, all of that is done with the Debian package we install. That's part of the installation script. We create these files here. But also creating a new supported operations for on the device is fairly straightforward as well. So I just need to create a file, Finage operations C8Y. Oh, I can't remember any new operations, but let's say it's going to be C8Y monitor or something. And just by, oops, sorry, specials. Right. So now a new file has been created, and this declares the new operation. So whenever I now start my mapper again, so this is currently a manual operation. So whenever I add new operations, I have to restart the mapper. But I think we have very short future plans to make it more dynamic. So we're going to put a watch on this directory. So whenever a new file will be created, that mapper should be able to pick it up. Oops, sorry, I should have shown you that. So now all the operations have been picked up, and my device have been. Obviously, we will not see the C8Y monitor because I think it's not the default with the operation. But if I go into my watch here, you can see that all 4 operations I have declared are supported. Okay, so that's pretty much. I'm done with the demo. So now everyone can add new operations. So what are the requirements? I'll go a little bit over the design and the spec of that. So as you already have seen, that is all controlled via a file system interface with Finage components. Currently, the main component for reading these operations is the Cumulosity mapper. And the way it works, that each operation will be read from the file by that mapper and will be declared by mapper. In the current version, if we need to, or if the operation needs to do some additional stuff, like let's say send additional statuses or send some reports, it has to do all by itself. So what I mean by that is that all the MQTT communication has to be handled by that executable which handles the operation. At 0.5.0, finish will kind of be an independent just reported of that. We have specified the option for finish to handle some simple cases, we could say, where the file will contain some configuration of that operation, but that's planned for the future releases, so maybe I'll not go over that for too long. So yeah, now if you need to add new operation, which is going to be visible in Curiosity and give you the control, just add the file here and restart the mapper, and that will be reported. And yes, it's now extensible.
And I think you can hand over to Albin for the Apama plugin for software management.
So yeah, today I'll be showing you the new software management plugin that we have developed for Apama. And using this plugin, you can install Apama projects as well as inject or remove monitor files from an already existing project, from an already installed project. So this is the one official plugin that we have developed. And I've got here on this machine, I've got it installed at this location /etc/sm plugins, which is where all software management plugins need to go. The default APT plugin is there, and along with that, we have the Apama plugin. Okay. And on this device, currently there are no projects installed. So if you try to run, I've got Apama installed. So if you try to run the Apama engine inspect command, you will see fail to connect because there is no project installed. So the correlator is also not running. So there is nothing. And now, using the Cumulocity software management functionality, I will be installing one project first, and then I'll be injecting one more monitor file into the installed project. Okay. So now heading to the Cumulocity UI. So to install a project, you first need to have it in your Cumulocity software repository. And since the Apama plugin, as I said earlier, supports two kinds of artifacts, right? It lets you install projects as well as monitor files. Okay. So to differentiate between these two, we have introduced some naming conventions. Okay. So when you create a software module entry for a project, say, for example, this Apama Quick Start project is one such project. So the naming convention is that the name needs to be suffixed with this : project suffix. Okay. So it can be any name that you want, but it should have a suffix that basically tags it as an Apama project. Okay. And then in the versions, you need to have this : Apama suffix. This tells Thinedge that this particular package needs to be installed using the Apama plugin. So earlier when we had APT plugins and APT software modules, everything had : APT, saying that, okay, that module is an apt module. So here it's : Apama. And yeah, since projects don't really have any explicit versioning, I don't really have any version here, but otherwise you could put some version values as well, no issues. But yeah, it should end with this suffix. And then you need to attach the project file, the project itself, in a zip archive, which contains the project directory, the Apama project directory. Okay, so that's the convention for Apama projects. Now, similarly, you can inject monitor files as well. So for the monitor files, once again, a similar scheme. The suffix, the name suffix should be : mon. Okay. And then in the version, you have the version followed by : Apama suffix. Once again, it's the same suffix, Apama suffix here, because a mon file and the project file both are going to be installed using the same Apama plugin. So that's why you have the same suffix here in the version. And then obviously you have the monitor file as an attachment. Okay. So now that we have all the necessary packages, we'll try to install one on my device. So here is my device. Awfully slow to load. Shall I? Yeah. Okay. Heading to the software section, and we'll try and install. So there are no projects installed currently, so we'll try to install one project now. So I picked the quick start project, install, apply, and wait. Yeah, so you see, installation succeeded. Now, if I head back to the device, and if I run the same command, which lists all the installed artifacts in the Apama project, you will get an output with, say, listing the monitor that's already installed. Okay. And this monitor, the functionality of this Apama monitor is very simple. So if you send a numeric value to an internal topic, it will convert that into a thin edge measurement JSON. So just to showcase the functionality, so here in the second tab, I'm listening to edge measurements topic. Okay, so that is the transformation that this plugin will do. And using Mosquito Pub, I am publishing to this internal topic demo number. This is just a random topic that's used in this project. And we are sending a number. And the transformation that this monitor will do is that it will just increment one value to this number. Okay, and then the final output will be in a thin edge Apama, thin edge JSON format. So I'm publishing it, and if you see here, you've got a measurement, touch measurements with the number. The value is 3 + 1, 4. Okay, so we've got the monitor installed. Now we'll go back and try to inject an extra monitor file into this already installed project. So for that, I'm using this TEDge test monitor. I'm installing the version 1, apply it, and wait. And as you can see, if you refresh, reload, yeah, as you can see, all the Apama artifacts are getting sent back in the software list. So there is the project itself with the project suffix. There is the first monitor that was part of the project, and here is the new monitor that we just injected. Now head back to the device, and just to be sure, run the inspect command, and yeah, the new monitor, test monitor is also there. And then yeah, similarly, you can even update it. So for this test monitor is also something that functions similarly. So if you send a measurement to this demo number topic, this new monitor will actually multiply it by 2 and then generate an image measurement with that. So I'm sending, say, 5. So I should get a measurement that is 10, which is the result of the. And here, as you can see, the first monitor is still working. It's still incrementing the number by 1. So that's the first monitor's output. And this is the second monitor's output, which is multiplying it by 10. And yeah, you can update packages as well. So updating it, apply, wait. And so the new version, what it does is it multiplies a number by 3 instead of 2. So that's the update. So I'm testing with the same number, 5, and this time you can see the previous monitor is still there, incrementing by 1, but the test monitor, the updated test monitor, is multiplying by 3. Okay. So yeah, that's basically all the major functionality that's supported by this plugin. And obviously, you can remove an individual monitor file. Apply that, reload, and you'll see that it's gone from the list. And if you come back and inspect, you'll see that the test monitor is gone. It's not there anymore. And one final thing, if you remove you can uninstall the whole project as well. So if I remove this project, it will basically take this project entry as well as this monitor entry, which is part of the project. So remove it, apply, refresh. Yeah, everything is gone. And I run the same inspect command, and this time, yeah, Apama is shut down because there is no project. So we remove the project and then shut down Apama as well. So there is no correlator running. So yeah, that's all the functionality that I wanted to show you this plugin. So the key thing to remember is that naming convention that will identify whether you're trying to install a project or a one file. And to find this plugin, so tomorrow or in a day or two, you will find a 0.5 release with the Debian package. So this plugin is actually installed using the Debian package. So this is an older version, but you will see the newer version with monitor file support and project support. And here is another repository that might be of interest to you, the Net.io examples, under which you can find some Apama projects, test projects that you can play around to basically try out or test this Apama plugin. So this is something that the Apama team is maintaining. And here you've got instructions to install Apama itself, and then further instructions on how to create an Apama project, install it, etc., etc. So yeah, there are a few. There is this quick start project that I just used in the demo, and then there is another limited bandwidth project. That's something that does something different. All the instructions are there, all the README files, and everything is pretty much up to date. Yeah, so that's all I've got to show you today.
Over to the next demo by Alex.
Yeah, thanks everyone.
Okay, hello, welcome. I'll be showing logs from your ThinEdge device. So I've got I've connected to my Raspberry Pi, and the logs are normally in varlog tej agent. There's currently 2 log files, but for this example, I've got this log request manual test file that will create just some extra logs. So if I run this, we will see that I've created some example logs. There's 2 example logs and 1 test log, and they are dated for December 3rd and 4th. Okay, and I can show you like the contents of one of these logs. So it just contains some random entries from the actual logs from the software list, plus a few just just a few error entries that I've entered myself. So if we go to Cumulosity, if I just go back to home, all devices, you choose your device, and then you go to logs. You can request a log file here, and I'll request for those example log files, and that was it was 3rd and 4th, so I'll just do from the 2nd to the 5th, just so I make sure I have I don't want to have to define the time there. And the type is software management. I'm not filtering by text this time. I'll want 1,000 lines, and I'll request it. That was successful. To view the log, you go to events, and you see that this was created just now. You can click download. This is how you download them, and you can see the files here. And we have the log file. So there's 1,003 lines. I requested 1,000, but that's because we have these file name entries. So we can, if I search for file name, we see that there's 3 of them. So there was 3 files from where we got the logs, and the first file had 500 lines, and then the second had the remaining, and then finally the last one had the rest of them. So that's why there's 1,003 lines. But we can also, if I go back to requesting a log file and just make the same query between the 2nd and 5th, you can also look for something more specific. Like if I just want if I want just entries with the word error in it and just the last 10 entries. Okay, I got scared for a second. And I download. Yeah, sure enough, we get these entries. 10 lines of error and also the file name. Yeah, I think this is all I had for this demo, for the log request demo.
Okay, I think then we can progress on to restart.
Okay. Yep. Okay, so that's also with me. Restart. Okay, so restart, you can find restart. You can restart your device if you go to control. There's this more, and there's a restart device. What you need for that is to have the Cumulosity mapper running. So I'm just going to run that right now. Sedge mapper sm c8y. Yep. Okay, and then you do restart device. I also need Sedge agent. Okay. Yeah, okay, as you can see, my connection has been closed. Which hopefully means it's restarting. Okay, sure. So if I can now start the agent and start the mapper. I will have to do this again because I'm not sure why this didn't update to executing. So I will just cancel it. And okay, yeah, because it didn't update, it got the same restart, the same reboot operation again. This should have updated to executing. So I'll take a look into that later as to why it didn't. Okay.
So worth mentioning maybe about this feature is also that, so of course it's also about the restart operation itself, but it's also an example how operations can or should be implemented if you want to have them locally available. So that for restart, you can trigger it from Cumulosity Cloud, but you can also have the possibility to trigger it locally. For example, if you have a Apama rule and something is going wrong with the device, that the memory is to overload us anything, and you can create an operation locally to restart the device to handle that. So it's not only for Cumulosity Cloud, but also locally available.
Okay, yeah. So right, now that I have the components running in the right order, I should be able to do restart. And now this is set to executing. The connection has been closed, and just wait for it to come back up to update to complete it. But that's pretty much the feature. Okay. And Okay, and this should update. I need to run it again. As I was doing this, I noticed that it took a while for us to update, and I'm not sure if it's because I'm not running this in the right order, or my setup here is a bit suboptimal. But it'll update soon.
Yeah, usually, of course, that would be a little bit different.
There we
as
go.
the,
Okay.
Yeah, when the binaries actually run as services as intended on finished actual installations, and starting in the right order because of that then.
Yeah. Okay.